Alright, good evening. Let's get started. We're looking at day number 11. So, question 1. Adrienne, Sara, and 3 teacher assistants all agreed to work on the upcoming math unit. Yay, math. Adrienne finished 1/3 of it. Sara and the 3 teacher assistants split up the rest of the work equally. What fraction of the work does Sara still need to do? So all we care about is Sara. So since we're talking about fractions and then we're splitting this up, so this is going to look like more fractions, we could do operations with that, or we could draw a picture. So what I did is I took this whole math unit, whatever it is, and I just represented it with a box. So this is our one whole thing. This could be one anything. Then it said Adrienne, she finished 1/3 of it. So what we can do is we can split this into thirds. And we can say this girl, Adrienne, she did all of this. So this part of the work is done. So 1/3 is finished. That leaves 2/3 for Sara and her 3 buddies. So if we consider we have these 2 pieces, or 2/3, and we have 4 people to do that. So how can we split the work between 4 people? Well, we can take this and we can break it into 4 pieces again. So we can say 1, 2, 3, and 4. And so we can say how much of that is Sara doing? Well, Sara would just take 1/4 of this, but she doesn't have to do this section in blue because Adrienne did it for her, so all she needs to do is this block and this block. So how much of the work did Sara have to do? She had to do this. So what is this as a fraction? Well, that's 2 blocks that she finished out of how many blocks are there? Well, this is 3 columns. Yeah, 3 columns with 4 rows. So 3 times 4 is 12. There are 12 little boxes. And we can simplify that. 2/12 is the same as 1/6. So our answer, Sara did 1/6 of the work. That's it. So anytime you need to break fractions into fractions, just draw a picture. Probably be the simplest way. Alright, number 2. The largest cookie in the world. I approve of this problem because I like cookies. Was made by this baking company in Flat Rock. Oh, also it's in USA, because who else would build the biggest cookie ever? Alright, the 17th of May 2003 had a diameter of 101 feet. What was its circumference? So we need one giant cookie. Okay, that's awful. Let me try that again. One giant cookie. Alright, there it is. And it has a diameter, so all the way across the center is 101 feet. So what is the circumference of that? So we need a formula for circumference. If we look at a formula chart, we would know that's either 2 pi times r, or c equals pi times the diameter. How do we know which of these formulas to use? Well, it tells us the diameter. So let's use the formula with diameter. This reminds me, I have like a 40-minute movie somewhere that talks all about circles. I should probably load up, huh? Alright, anyways, we can fill in our numbers. We're solving for circumference. We know this diameter is 101. And just for kicks, let's say pi today is 3.14. So then this is just a multiplication problem. What is 3.14 times 101? Oops, there's no decimal. Oops, I didn't mean to delete all that. 3.14 times 101. And let's multiply this. So 4 times 1 is 4. 1 times 1 is 1. 3 times 1 is 3. We can go to the second number, but anything times 0 is 0. So we go to the third number. Since it's in the hundreds place, we need to bring down 2 zeros. And then we just multiply by 1 again. So we're going to get 4, 1, 3. If we add these together, we would get 31714 feet. Well, actually that's not right because we need to remember our decimal places. So we have 2 decimal places up top, none on the bottom, so we need 2 decimal places in the answer. So it's actually 317 feet. That's the circumference, so the distance around the outside of this cookie is 317 feet. That is a lot of cookie. So, in case you don't believe it, bam, there it is. There is a cookie, and there is a man standing on a cookie. I would like to, at one point in my life, stand on a cookie. Alright, I hope that's impressive. Go Google this. This is pretty interesting how they made this. Alright, number 3. Large box holds smaller boxes, 12 of them. The smaller box measures 5 centimeters by 2 centimeters by 3.4 centimeters. What is the volume of the larger box? So what we're talking about is we're going to have boxes that are kind of small. So we can draw our small box here. And what we're going to do with that is we're going to see how many of these boxes, or no, wait, we don't want to know how many. We know how many. We know there's going to be 12 of them. So if we take 12 of this box, how much would that be? So let's just real fast, we can throw down 12 boxes here. So that's 8, 9, 10, 11, 12. There's our 12 boxes of boxes. So I know what is the volume of this whole big mess. So let's figure out what was the volume of our original box. Our original box. So for right now we're going to get rid of all these. And we're just going to look at this one box. So that we said is 5 centimeters by 2 centimeters by 3.4 centimeters. So we can find the volume of this. We can say volume is the area of the base times the height. And the base on a rectangular prism, because it's a rectangular box, we know is just length times width. So we can say what is length times width times height here? So we just multiply this out. So we say 5 times 2 times 3.4. And this part is pretty simple. 5 times 2 is 10. Actually, that's pretty simple. The next part too. 10 times 3.4, that's just a matter of moving the decimal place over. So 10 times 3.4 is just going to be 34. So that is the volume of one box. This one box was 34 centimeters cubed. So now if we come back, we bring back all of our other boxes. Where are you other boxes? There they are. If we bring them back, oh no, if we can move them back like that, how much volume would all of them have? So it'd be 34 in each one, so we can say what is 34 times 12? Pretty straightforward. The volume per box times the number of boxes will give you total volume. 4 times 2 is 8, 2 times 3 is 6. We go to the second number, we add a 0. 1 times 4 is 4. 1 times 3 is 3. Add those together, we're going to get 8, 10, 4. So what is the volume of the larger box that holds all these tiny boxes? Is 408 centimeters cubed. That's it. There is number 3. Is that number 3? I think that was number 3. Yeah, number 4. Alright. I was hoping these were getting easier, but we saw a lot of people having trouble with this, and that's okay. So what quadrant does this ordered pair lie in? So we can make our little coordinate grid and just look at different ways. If you've understood it the ways we've been doing, just keep on doing that. But let's think of it. There's y and here's x. Instead of thinking about it in hemispheres, taking about half of the time, let's just look at each quadrant on its own. Let's look at the properties of each quadrant. 1, 2, 3, 4. So if we think about the properties of quadrant 1, we think our x values here, if this is a number line, here's 1, 2, 3, all the numbers on the right side of that would be positive, so we can say it's going to be positive. And all the y values, since this is going up, we notice are also positive. So we can say any coordinate or any point in quadrant 1 is going to look like it's going to be positive, positive, which is not the case for our point here. This is, of course, positive, negative. So we're looking for the quadrant that looks like positive, negative. So let's go to quadrant 2. If we go to quadrant 2, we have negative numbers on x. We look at our number line. So x would be negative, but y is still going up, is still positive numbers over here. So we have negative, positive. Any point in this quadrant is going to be negative for x, positive for y, which is not what we're looking for. How about quadrant 3? Hopefully you can answer these before I can even write them. If we consider x still on the left side, that's still negative, and our y value, number line's getting a little messy here. Hopefully this still makes sense. Our y values are going down, so these are now negative values. So in quadrant 3, you get the sleepy owl. X is negative, y is negative. Both coordinates are negative. Again, still not what we're looking for. So hopefully we're in quadrant 4. In quadrant 4, our x values are all positive. On the right side, all these numbers here would be positive. Looking at the y value, all these numbers on the number line are negative, so our y value needs to be negative. So anything in quadrant 4 is going to be positive, negative, including point positive 9, negative 5. So our answer here is quadrant 4. Quadrant 4. Okay. All right, number 5. We did some of these in class, and it was kind of confusing. Some people that we had exponents and then exponents outside of the parentheses. So what do we do with this? Well, remember, we always consider this. We always look at what's in the parentheses first. We think of this as its very own problem. So we want to solve. That didn't really space out as well as I wanted it to. We want to solve everything in these parentheses. So if this is its own problem, we have addition, we have exponents. So we've got to do that exponent first. So we say 3 squared. I guess I can't write while I have it like this. Okay, so I got to close this. You get the idea. So we have to do this exponent. 3 squared, or 3 times 3 is 9. And then that's plus 14. And I'm just gonna bring everything down. So now we still have parentheses, so we have to finish parentheses. So 14 plus 9 is 23. And we don't really need the parentheses anymore, so it's just one number. So now we have 23 squared. So what does 23 squared mean? Don't try to say it's 46. This is 23 times itself, times 23. So we just have to multiply that out. And we get 9, 6, alright, bring down the 0, and then 6, 4. If we add this together, we get 9, 12, 5. So what is the value of this expression? Or if we simplify this, depending on what the question asks, this is just equal to 529. Alright? One more to go. Oh my goodness. I'm not going to make it, but we're close. Find both the complement and supplement of an angle which measures c degrees. So we've done this. We've done complement. We've done supplement. But this might be where we get confused. What does it mean by c degrees? Well, c just represents any number. It can be any number we want. And if that's still kind of confusing because you're saying, well, how do I find the complement of a number I don't know? So let's assume for a second, let's just say it's 20 degrees. We're just going to pick just some random number to be our angle. So how would we find the complement to 20 degrees? Well, remember that complement means it's two angles that add to 90. It adds to 90 degrees. So how could I figure out what we could add to 20 to get to 90? And a lot of you are probably thinking, oh, that's just 70. But you got to think, how do you get to 70? You'd probably say, well, what is 90 minus 20? And that gives you 70. So the complement would be 70 degrees. And that works for 20. But how can we say that same idea except using any number? So instead of saying 20, what if we said 90 minus c? And obviously we can't figure that out because c is not a number, but this idea still gives you the answer. So we say, what is the complement of c degrees? Well, it's 90 minus that angle. The same way that the complement to 20 degrees was 90 minus that angle. It's always that. It's always just this idea of it's 90 minus your number. And that's it. That's all we can do. We can't simplify that because c, we don't know. But then we just have to think there's one. Actually, let's do that at the end. Let's talk about supplement first. Let's get that out of the way. So supplement's the same basic idea, except we just need to remember that supplement means it's two angles, two or more angles that add to 180 degrees. So we can take this same idea, and hopefully we've picked up on that at this point. Instead of saying 90 minus c, now we can just say 180 minus c. So the same thing, it's whatever this angle is, we take 180 from it, and that's the supplement. That's the angle that goes with it that'll make it add up to 180. So like I alluded to before, just to close this out, this statement is true, but we've talked about it. Not all angles have a complement. When would this not work? Well, remember that angles can't be negative, and they can't be zero, so this answer cannot work out to 0 or lower. This can't be negative. So how big can c be? What is the biggest number c could be? Well, if we said, let's see, c, if c was 90, just for an example, would there be a complement to that? Would this idea of 90 minus c work? Because that would look like 90 minus 90. And you can't, that's not going to work because then your complement would have to be 0 degrees, and that angle doesn't exist. So c can't be 90, and it can't be anything bigger than 90. So c has to be less than 90 degrees. Because if this is a right angle or obtuse angle, it doesn't have a complement. And the same thing for supplement, this angle would have to be less than 180. And if that doesn't fully make sense, that's okay. If it makes a little bit of sense, that's good. If it doesn't make any sense, come and see me after school. We'll talk about it some more. Okay? Good night.